Look at that P. Okay, we gotta try to solve for this N. Okay, in order to do this, you gotta know what the P means, permutation. So we're trying to find this value of N right here. So I'm gonna rewrite this without that P. So it's gonna be N factorial over N minus 3 factorial. And then on the other side of the equation, I have N plus 2 factorial over N minus 4 factorial. Oops. N plus 2 minus 4 factorial. How are you doing this? Guys, remember this. Remember this formula. If you had N permutation R, that equals N factorial over N minus R factorial. So I'm just plugging this stuff into this formula. The N right here is N plus 2. So that's why there's an N plus 2 factorial up top. The N minus R on the bottom, the R is 4. So it's N plus 2 minus 4. Now I can simplify that. What does that simplify to? That's N minus 2 factorial. Okay. So do you guys remember how to simplify factorials? I forgot my parenthesis there.
Yeah. Where did you get 14?
Where did I get 14? The 14 is chilling right here. The problem. All right. I'll simplify the left side, then you guys are going to simplify the right side. For left side, I'm going to go N. And what is 1 less than N? N minus 1. And then N minus 2. Why am I going to stop at N minus 3 and put a factorial on that? Yes. Because then I get to cancel out these guys. All right, you guys try the next one before I do it.
Okay.
Okay, here we go. I'm going to expand the top. N plus 2. N plus 1. N. Then, or I could say N plus 0, but I'm not going to. I'm lazy. N minus 1. And then N minus 2 factorial. That's being divided by N minus 2 factorial. Those get to cancel out now. So, now what do we have? We have 14 times N times N minus 1 times N minus 2 equals N plus 2 N plus 1 N and then N minus 1. Okay, if I do some dividing to both sides, which is kind of dangerous because that means we're going to lose some of our answers. Actually, maybe we should be just subtracting that from the other side. I'm not sure if we can do this. I got to double check. Sorry, guys. But if I divide both sides by N, those will go away. If I divide both sides by N minus 1, those will go away. Is there anything else I could divide to make go away? Nah. So on the left side, I now have 14N minus 28. And on the right side, I have N squared plus 3N plus 2. So I multiply everything out. Now we have a regular quadratic function. Can we solve it? Yes, we can. Okay. So I'm going to put everything on one side. I'm going to put everything on the right side. So I have 0 equals N squared minus 11N and then plus 30. Can you guys think of two numbers that multiply to 30 and add to give you 11? So N minus 6, N minus 5 equals 0. Using the zero product property, we get 6 and 5. But see, now this is what I'm getting for my answers, for my N's, and we can test them to see if they work. But I think there's a problem right here. If I'm canceling out these N's and I'm canceling out these N minus 1s, I might be losing answers there. But I'm going to double check on that.
It says
plug it into those.
All
right, so you're just saying that in the book you saw that the answer is only 6 and 5? Okay, then this must be the way to do it.
Yeah, it says
How do you know?
5 or N equals 6.